Okay, we started the recording, so thank you everybody for joining today. This is the first Nephew SIG Automation Machinery meeting. Let me share the agenda. Okay, did that work? Did it start sharing? So as I mentioned in the previous meetings, I know we probably have a lot of the same people here, so this will be a repeat, but I don't know, whether we have new people as well. The TSC, I guess, didn't get a chance to meet and sort of firm up the policies and the kind of operational procedures yet. So that means that we don't actually know how to select our chair and vice chair. So I'm facilitating this meeting for now, and Stephen has some things to present, but we will hopefully soon have a way to do that, and we can make those decisions. That's, I guess, the other thing to talk about here is sort of what this SIG is. We've talked about in the previous two meetings this week, the SIG network architecture is really sort of where we will understand the use cases and the sort of information modeling, I think, is one of the topics that was brought up there earlier this week, and build out the requirements. And then in SIG release, which we had on Monday as well, that's sort of project administration is part of it, and then the other part of it is all the tooling around builds, CI, CD, test infrastructure, all of that stuff. This SIG, being automation machinery, is really about kind of the meat of the telco aspects of Nephew. So if we think about Nephew as a platform that in and of itself doesn't necessarily have a telco, flavor, the real meat of it and the real business logic and application logic and the thing that implements what network architecture SIG came up with lives in this SIG right here. So this is where we build, we take that information modeling that they've done, we take those use cases that they've done and sort of figured out, like, here's the most important thing to address first, and we determine the actual APIs, the CRDs, that are going to define some aspect of that problem, and then the controllers that are going to operate on that, and that can extend both to controllers living in the Nephew cluster, the central automation cluster, as well as to controllers or operators living at the edge cluster or whatever it may be. So, and there'll be an interplay between those to some extent, not at runtime, but though there's some handshake through the configuration itself between those. So that's a lot for this SIG, actually. It's I think in our very earliest draft and in our last SIG release meeting on Monday, I mentioned this too. All of these SIGs are a rough draft, right? We're a community. We'll figure out what SIGs we need. This is what we think we need right now. And we may determine in a month that we need another SIG, or we want to collapse a SIG, or whatever, right? Or we want to shift things around. But in our original earliest draft, I think this was split into two SIGs actually, and we combined it into one because we feel like they're so closely linked. And those were sort of there's a set of tooling we're going to produce, or maybe not tooling, not the right word, but libraries and things that vendors who are building operators can consume, as well as there will be actual controllers that we build that run, say, in the Nephew cluster that manage the automations and deal with that sort of higher level orchestration piece. And so that's what I wanted to talk about. I think Stephen has some things to go over as far as that's concerned. Stephen.
Hey, hello. So, well, basically more like repeating what John said a little bit. So we are, I think during the summit, we talked about this SIG. What's the responsibility? What is some of the essential outputs? Oh, I have some echoes. What's the essential outputs of the SIG? I mean, this is going to be decided when we decided the chairs and vice chairs and things. But then for now, in a high level, I think there's an expectation that this is the group of folks that will be coming up with the custom resource definitions as the first step. They should, in normal flow, be coming based on the requirements given by SIG-1, by Network Architecture SIG. Based on Monday's meeting, obviously, we may have to make some suggestions and propose sort of a high-level use case on the first level of CLDs that we go, because without that, we probably wouldn't be able to go on that much. And that, when you're proposing a custom resource definitions, we don't want it to be random and whatever we want it to do. So they should be backed by some sample operators to implement that custom resource. And obviously, the operator itself needs to be backed by some sort of implementations. And then the idea would be that should come from some open source projects. I think all of us has worked with some vendors, 5G core or RAN vendors, core particularly. In this case, most of them, a lot of them, I mean, I wouldn't say most of them, a lot of them have things like BGP to get routes across, whereas most of the OSS projects that we know of aren't having it. So it could be more than just, for example, taking a 35GC as a sample, because you may want to define CLDs that would help setting up routing protocols, and then maybe that's backed by like Bird or something, and then see how that get connected with the network functions that we're going to pick as a default. There will be, so I think we talked about that during the summit. The CLDs are expected to be more layers. There are different layers. There's a deployment level of concerns where most likely on the telco space, it will be a different persona, like say network designers, that will be expressing an intent of, oh, this is what my deployment looks like. And then obviously it goes all the way down to what gets into the Kubernetes API server on the target clusters. That high level intent all the way down to what actually defines, let's say, UPF or OIC or DU, would go through a set of transformations. Or for John, probably will talk about that a lot more tomorrow for the SIG platforms. For us, for what Google will be open sourcing, it will be based on a bunch of tool chains that is already open sourced, CAP being one of them. So for early samples, for sure, we'll have some CAP functions to do the transformations, and then for transformations, that means you would have a pipeline, a sequence of things that dissolve a high-level intent down to what is actually being consumed by the Kubernetes API server. That pipeline would also be defined by this SIG, obviously, because we have to implement it. And that should be vendor agnostics to a certain extent. And the tools and supporting infra for getting some of the vendor operators to be on board. What we really want out of this SIG at some point is there will be a lot of network function vendors in the communities that would be talking about what CLDs they want, and then at the end they would also be supporting the NetField custom resource definitions. And then I would imagine most of them know how to write operators, so I'm not going to say we would create something that would help them write operators besides what the common tools are. We may actually find out that by writing samples and writing other things, that we have common libraries of things that are useful, and then we'll publish those. And then I think we also talked about that during Summit. There could be cases where Nathio needs to be managing a central database, because we'll be understanding if a particular vendor's operators is supporting a particular version of our Nathio CLDs, and then we'll maintain a central database to see if this vendor's network functions, this version of that vendor's particular network functions, what kind of. Yeah, go ahead, John.
Oh, sorry, I didn't necessarily mean to interrupt. That was just when you were done. Just thinking about some of the things you're saying, like, okay, there's certain particular narrow use cases, like we don't have the full use case from network architecture SIG yet, but there's some narrow pieces of functionality that we suspect, or we have backing to. I mean, should we start looking at what those CRDs might look like BGP configuration or something like that? Another question, or even looking for point solutions that might already exist, like operators that manage BGP solutions may already exist.
Yeah.
And another,
SLIOV operator, for example, is already it's really widely used, so we can pull those in. Yeah.
Right, but what I guess, so stepping back a little bit, like, given the scope of this SIG, one question I would ask is, what are the areas of risk? What are the areas that have the most questions and uncertainty that we need to resolve earlier, that are going to affect the direction that we go? So you know, we talked about earlier this week, I'm putting together sort of a very simple scenario that we can use to explore the overall machinery, and that will cover partly platform stuff, and it'll cover partly this SIG stuff as far as how you configure this DNS application or whatever.
Right.
And so I'm going to publish that use case this week. I haven't, probably tomorrow, most likely. But we may want to do a similar thing with some of the specific functions that we think would be more real world. Like mine's like it's caching DNS, which has some certain advantages, like zero state. It's easier. Like, I think Tal, I know you've got your hand up.
Yeah.
Yesterday.
So that's actually more the next bullet point. So I'm working on pulling the seed code. If you call it seed code, but at least a sample to get started.
Before we jump deep into code, I'd like to think about, like, what are the areas, brainstorm and ask folks here what they think the areas of risk are, like uncertainty, unknowns, where are the biggest unknowns, and that we can explore with whatever. I know we have seed code that we've been working on that we will also be sending or sharing, but I think just sort of trying to think about bigger picture within the constraints we have of, like, open source and all this, like, what are the areas of risk we can explore? But before I mean, Tal's got his hand up for a while.
Yeah, go ahead, Tal.
Thanks. Yeah, the issue of risk is interesting. We can get into it, but I first want to go back a little bit to the issue of scope and what's included in the SIG. And one thing we discussed in the workshop was the necessity for best practices for operators, and possibly that Nethia would have an SDK of some sort to make it easy to join. So I assume, looking at all the SIG, that this is the SIG that would own that SDK potentially. And it does move us to risks, right? John, you said, everybody's familiar with operators. It's true, but it's still very challenging to write operators and write good operators too. And there have been numerous attempts to create best practices. I know some of you have read my document that I shared about CNS and operators. This is a risk for us, right? Because they're decisions we have to make. We want to be opinionated, right? If we have an SDK, there's going to be an opinion. Of course, anybody can write an operator in whatever way they want. But if we want to kickstart, jumpstart, move people forward as quickly as we can, there needs to be an easy way to onboard into Nephio an operator. So I raised the question too, right? Are we? There are nuts and bolts questions. Are we going to standardize on Go as a language? Are we maybe looking to Python? Maybe support both? Of course, at the end of the day, we support everything that people writes. But if you click on download Nephio and there's a quick start page, how do you get your network function running on Nephio? We want that to be as a quick, clear, unambiguous experience as possible, right? So I think that is the big risk, that just how challenging this is technically, right? Remember too that a lot of the engineers working on network functions are not cloud engineers necessarily. They're network engineers. They're very good at creating these network functions and making sure they run well and everything. They're good also at understanding the move to containers and what that means in container networking. But the whole machinery of Kubernetes and cluster management and all that, that's an entirely different realm of engineering expertise, right? So our risk and challenge is to bring those together in as seamless a way as possible. And if we do that, we succeed. We already moved the industry forward, I think.
So I couldn't agree more. And this has been, and I think we talked about this now, it's like a month ago, right? And it's been an area of concern because it's hard enough for people who are experts in Kubernetes to write good operators, much less people who are vaguely familiar with Kubernetes or familiar with it as a user, as opposed to as a developer. So I guess we're not, if somebody, I meant to do this, like, can somebody volunteer to be a note taker? And you use the same document right there, just like Steven started adding some things, but like we can put some action items in. Like I've actually initiated that process internally to try and start to generate some material around that, but it's not been on my front burner. And I wouldn't be generating the material, but to work with folks at Google who have done this. I know that there's folks at Red Hat also who've done this, right? There's folks at some of our companies internally that have built really challenging APIs and operators, and we may want to look at putting together some materials to make that easier. Jean-Marie, did I say that right?
Jean-Marie, I guess.
Yes, Jean-Michel Mel from Nokia. I think we need first to agree on what is our criteria for saying it's a good operator, it's not a good operator. And that criteria needs to be essentially or primarily based on what is the intent level CRDs that are exposed and managed by this operator. But we need to qualify and agree on those quality criteria.
I mean, there's yes, for sure. I think there's a few things that are indisputable, like it has to follow proper distributed system patterns around, how it manages concurrency. And like, unfortunately, the Cube libraries, although they offer some help with that, they don't solve the problem for you. And if you haven't built distributed systems, you may not be aware of some of the kind of issues that you can run into, and it's just not all that well documented how the expected, like, well, if I try to write this and it fails, I reload it, and that, because the resource version has changed. Like, there's just like some of those things are documented, but the documents may be scattered. So I think those things are indisputable, I would say. Are there other things that are more subjective?
I would add a big risk for that is day two. You look at so many operators out there. The vast majority of operators are database operators. They set up a database cluster, and they're very good at doing the initial setup. But then if you change the custom resource, you tweak it in some way, and okay, what happens now? So bad operators redo everything. They destroy the cluster and they build it from scratch. Now, that is bad. I think that's clearly to everybody bad. The good operator would be able to intelligently, smartly see what needs to be done to reconcile things and do it as efficiently as possible with the minimal downtime that you can do it. So there are certain objective criteria that we can put. Of course, it's subjective as well, because it depends on the semantics of that individual CR. But it's not hard to make a list of what makes operator bad and what could be done to improve it.
Yeah, and I think that's a great point. And I think there's also, we talked about at the summit, like there's a distinction we want to make, and this is maybe more opinionated, but or more subjective criteria. For example, we want to manage individual. In the end, you end up with something in the Kubernetes API server. It's a resource. It's got a bunch of fields, or it's 50 resources or 100 resources, and they're got a bunch of fields and they're interrelated. That's the end goal for everything, whether whether it's an operator or whatever. The question becomes, where do the values in those resources, the presence or absence of those resources, come from? In my opinion, and I think in what we want to do in Nefio, because of the way we want to enable the management, if those values are 100% determined by the operator, then, so for example, an operator that just takes a bunch of inputs and renders a bunch of YAML, essentially effectively running Helm internally, you end up with a situation where any change, any deviation from what the operator often had in mind in the beginning requires code changes.
Looks like he's frozen.
To be written, and that's fine. But for most of our cases, what we see is that customers have very different situations they're dealing with and want to make little tweaks. And those little tweaks shouldn't require building a whole new operator and rolling out a whole new operator. They should be able to do that somewhere in the pipeline. Typically what's done today is that those things are in a Helm chart, and we're trying to make something better than that, where we make it so that people can, and this is part of the CAD thing, which we don't need to talk about here, but where we enable people to make those sort of changes without having to change code in a Helm chart. So I think the reason I'm talking about this is for sort of criteria, subjective criteria of what makes a good operator. In my opinion, part of being a good operator, and thank you for taking notes there, part of what makes a good operator is that it deals with the complex operational characteristics of that particular application. I mean, config SIG or Argo CD are effectively operators that just take YAML and apply them. So if all your operator does is that, just use config SIG or the Argo CD, right? So it has to have semantic knowledge of the application it's managing. It has to be, the reason databases tell, I think, is because good ones anyway should be thinking things like, I want to take a backup. Okay, I need to quiesce the disk, and I need it, right? There's like a 3-stage process I have to go through in order to do this operation. That I can do that in an operator. So anyway, maybe you get me talking. I'll just keep going. So like, I like that idea. Let's put criteria down, and I think that best practice around where some piece of business logic should live in an operator, in an FEO controller, in a kept function, just in the user's head that they manage the resource at the time of deployment. Or at least 3, or at least 4 stages.
Right. To maybe bounce off on some of what you said. By the way, you were cut off there for a minute, but I think we got the gist.
Yeah, my network's
that-
not weak yet. Sorry about that.
I think we got most of it. So it's one way to think of that kind of flexibility is extensibility, right? So we can think of in the telco world, we're familiar with the kind of ETSI terminology of SVNFMs versus GVNFMs, and the idea that you can have some sort of manager, operator in this case, that would be generic and programmable and could be applicable to many classes, say, of network functions. Now, I don't know if that would be the goal, like to have one operator that is completely programmable, but it could be the SDK would be part of that answer, right? So you have an SDK, and then people build on the SDK, and they share a lot of boilerplate code already. But extensibility can be thought of even for specific instances, even in the SVNFM use case, where we can allow for these operators to be extensible, right? So when I think, I mentioned in my document that there's this notion of what I call pure operators, that are the kinds that just take the custom resource and emit Kubernetes resources, right? And manipulate those Kubernetes resources. But there are impure operators that actually also do other stuff. They would do configuration of these components. So it's not just creating Kubernetes resources, but also interacting with them in some way, if it's calling APIs or generating files for them to consume, etc. So in that space, you could, in the impure space, you could potentially have an operator that could allow for plugins or something like that to be added to do extra work. So oh yeah, I will link that. So again, I don't know that I'm just laying out the problem field at this point. I don't think we're at the stage where we're going to come up with solutions, but just to, again, on the line of what constitutes something good, right? So what constitutes something good is something that's flexible, that's powerful, that's efficient. We can make a list of all these words and really specify exactly what we mean by them. But to me, flexibility is a big one, because remember that one of the challenges of operators is that on the one hand, they look like magic, right? You make a declarative front end, and then the operator does all the heavy lifting that supposedly a human operator would have done, right? And can intelligently, even using AI in some cases, make decisions very quickly to solve things. But in doing so, we have to write code, right? If it's Go, if it's Python code, etc. Now, if we want to tweak this later on, well, you have to go back to the coders, the engineers who wrote this code, and to modify the operator accordingly. So this is, again, a big risk factor. You asked about risk factor, that a lot of what we're doing here, we keep saying configuration is data and everything, but we're shifting the buck, right? We're moving all the work into operators, but that means that everything, all the code is concentrated there. So if we make that operator as flexible as we can, and we could avoid the problem of going back to recompile the operator with some change or tweak that we made. Just something to consider. And I'll share my document quickly.
So Stephen, this is Vish.
Vish?
So what you are trying to say earlier, I want to capture the summary of what you were trying to say is this output of this particular SIG is going to make the network function, the vendors that actually are the ones creating those network functions, it makes it easy for them to be able to deploy and configure the network function. That is what I think is the goal, right? I just want to summarize it.
Yes.
That is what I think.
We're hoping community members, that includes the network function vendors, would be building operators also.
Oh, okay.
With Nethiold's best practice.
Okay, so
and then we'll be able to use the same frameworks to make it easier for
okay.
So the same experience for users. So we have two classes of people, right? We have the telco users, we have the NF vendors, we have all of us non-NF vendors, and then we would like the users to get the same experience.
Okay. So the users will actually configure the network function.
There's going to be vendor differentiations. We're definitely preserving that, but then we'll also like to get things to get easier for the users to consume.
Okay, because I'm trying to draw a parallel with this. I mean, you are more aware of this. With OpenStack, we had the advanced network, function, right? Wherein we had actually all this load balancer as a service and firewall as a service, which was generic, and then we had vendors like Brocade and everybody else come in and try to plug into it. That is what I think this is trying to do. Similar approach, right?
Yeah. So
Okay.
OpenStack Parallel, as we talked about in Summit 2, is something like this. So we have the API sets, we have default implementations. We're hoping to rally the vendors to also implement on that API.
Yeah,
Okay.
yeah. If I can comment. I raised my hand to say something, respond to something Cal said, but
Yeah, go ahead.
I want to say something about that, and hopefully my network's working a little better. One thing we want to be careful of is is inversion of control. What I mean that is sometimes when you introduce an abstraction, like a firewall as a service or a load balancer as a service, you invert the control and you give the control to the abstraction. And so the abstraction defines some, think of subclassing in object-oriented languages often have this, where from the surface, the higher level abstraction kind of has dictates everything that happens, and it calls out to the lower levels to implement specific details. I actually want to switch that. And the reason is that tends to create rigidity amongst the implementations. It tends to push things towards the lowest common denominator. And if we push things towards the lowest common denominator, our vendors won't want to play, because why would they? Why would they commoditize their features that they and not have people not be able to access the really good stuff that they've built? So the idea is instead to give control to the vendors. They build their own operators. The common parts become something they consume. So instead of the common parts being the face that then consumes effectively the vendor-specific parts, we want the vendor-specific parts to be kind of in control and then consume the common parts. It's a subtle difference, and I don't know if I'm explaining it clearly, but I think it's just something I want to. When you hear things like firewall as a service, it makes my bells go off in my head. Like, we got to be careful here that we're not pushing people towards lowest common denominator. So
okay, yeah. I was only trying to use that as an analogy because Steve and I had worked on OpenStack, so I was only trying to figure out, hey, is this, because what I'm trying to figure out is the audience that is most interested here in this particular case, right? The output coming from here is the network function vendors, right? Who want to actually make sure that, hey, I want to play well with this because if I'm just trying to figure out who the audience that would be very clearly interested in for the output coming out of this particular SIG will be. What I gathered is, hey, if I am, for example, either FI or if I'm Palo Alto or something. I mean, in this case, I know we're talking about core net services, but in the case of RAN vendors who are coming up with the CU or DU, they might be very much wanting to watch this very closely. I'm just trying to figure out.
That's right on. It's definitely those are the people, yes. But I want to sort of think of ourselves in this SIG as working in service. So that, say I'm F5 and whatever, just pick someone right there, and I want to build something that's compatible with Nepio. I can just literally, I should be able to just literally look at the specs and write all my own code to do that. But if this group is doing a good job, then instead they should look at what we've produced as output and say, wow, that's going to shortcut my work to integrate with Nepio substantially. I'm going to consume that and use it. And so, in that sense, I view the uptake of our code as at least of that segment that's targeted towards network function vendors or operator authors as sort of an indication of how well we're doing.
So the success is measured by, hey, I'm a network function vendor and I'm able to integrate very easily. That's a measure of the success. How fast you're able to do that. Okay.
Absolutely. And then I'm sorry, Alexis, you have your hand up. I did originally raise my hand to mention something. Tal said we're shifting the buck, we're moving to the operators. I don't want to do that. I want to do what you said you want to do too, which is have the flexibility and offer the area of control in the appropriate place. There are things that are appropriate for operators and there are things that are not. And I think we need to be sure to put the the touch points for the right things in the right places. And that's part of, I think, the best practice and sort of opinionated stuff we have to write about. So.
Right. Just a very quick response. Extensibility can happen also in CRDs.
Yes.
So you can have a custom resource that is designed to have some area in it or section in it that is
Yes.
more configurable.
I expect
So, yeah, the
absolutely.
control can be there. But yeah, your point is taken. You know, where the control happens and where change can happen. Right. Again, flexibility, being able to iterate on features is. Yeah, we'll have to think of that carefully.
Yes. All right, sorry, Alexis.
Yeah, thank you. So I wanted to chime in a little bit regarding the Nephew CRD compatibility testing. And I wanted to do a parallelism with a lot of the work that has been done in OpenConfig today. And the reason I'm bringing OpenConfig, and I'm going to talk a bit about Yang, is some of the stuff we're talking right now about CRDs and extensibilities are also concepts that we had in Yang, right? So I'll leave that side aside for now. My goal was more to talk about more OpenConfig and what it tried to standardize. For instance, we talked before BGP config for routers. So this Nephew CRD that we will aim to build here, how much are we going to try to start from scratch based on the use cases we have? Or are we going to try to leverage some of these standardizations that happened? I mentioned OpenConfig, might be other existing open source communities building models or things like this. So yeah, my question is really, you know, a Yang versus a CRD, it's not the same purpose, but when we bring into the Nephew ecosystem, there will be some commonalities. What's your opinion here as a group, and how it will impact down the road some of the decision we make in this SIG?
Well, so my opinion is that we should leverage other people's work as much as we possibly can, as long as we believe it's, as long as it matches our philosophy. So some of the things I was just talking about, like if it forces lowest common denominator, then it's probably not going to work for us. If it can be done in a way, and I'm not familiar with this specific work, so I'm just sort of talking abstractly. So from my point of view, this whole industry is built on top of standing on each other's shoulders. So let's keep doing that. Otherwise, we'll never get anywhere. That could mean also proposals that come out of this group and tools eventually, or even an operator that consumes Yang in some way. And but I don't know enough about it to provide any kind of guidance around whether that's a good idea or not. But sort of philosophically, we are very open to consuming and leveraging other people's work. I don't see any need to go from bare bones. That's my opinion.
Okay, well, I'd love to have maybe later down the road more significant, deeper dive into really that Yang ecosystem that exists today and some of the toolings that exist over there versus the CRD ecosystem that we're going to build and some of the toolings we're going to build there. And with the mind that if we somewhat reinvent the wheel to be more Kubernetes native, let's make sure we learn some of the well, we benefit from some of the lesson learned from that Yang
absolutely
work
so
that has been done.
Yang, my understanding is modeling language. So that either sits on top of the CLDs or we would take that models and try to make it into a custom resource definition. They're not so much of a realizations. They're probably the model would still go down into say OpenConfig or maybe OpenConfig is something else or netcons or some other things to actually configure, right? So
yeah, there's a few folks with their hands up. So
yeah, go ahead. Yeah, Sean-Marie.
Yeah, so to that reuse, it's something that we should absolutely look at, but that's also why it's very important to have our quality criteria or acceptance criteria defined first, because the quality of the intent that we are expressing will be absolutely critical to the success of Nephew, or will be the instrument of failure of Nephew. And in particular, we'll need to strictly control the complexity of those intents, because complexity is the absolute enemy there.
I'll just finish my thought here is, and I agree. And what I want to make sure is we know how OpenConfig today is being adopted and where it works and where it doesn't work. Let's not make Nefio the same. Let's learn from where it did work and where it didn't work, and benefit from that knowledge.
I had a kind of more a higher level question in the sense that because and if you look at the southbound from Nefio, there are three basic APIs that are being defined. Right, one is for basically cloud infra and the cluster management, and then you have for network function orchestration and then network function configuration itself. And I'm assuming you would going to have custom operators for these three buckets of APIs. And so, I mean, so the basic idea is that you will have some, and I'm trying to understand, like, to have some kind of view of the workflow of taking this the CRDs to basically say provision of UPF and understanding that, okay, this UPF is a mid-size or basically high capacity UPF for handling, say, some dense urban kind of scenarios, and then basically checking that, okay, do you have the cloud infrastructure to handle this kind of workload, and then orchestrating it to fundamentally check if you have accelerator resources, IO resources, a compute and all that. So, I mean, I think some point you'll have to define this workflow, right? So that you get from the point of expressing your intent to kind of actually provisioning it. Because a lot of the discussion I'm seeing is kind of going tangential to the big picture that we want to achieve here.
Yes, that's a great point. I think Stephen earlier mentioned pipeline. That's kind of what he was about, that pipeline of how that moves forward. So there's two different kind of workflows. There's the user workflow, and then there's the automated workflow of how these different pieces interact. I think that tomorrow, we have the platform meeting. I'm going to try this afternoon, to get my use case publishable, and we can talk through that tomorrow. And I think it'll help illustrate some of that. And then I'll talk through maybe some of the pieces that I'll be building to implement that use case. I think that might help build some more clarity. As far as whether there's three operators, there's going to be dozens of operators, right? There's going to be, and they're going to fall in those different spaces. Each application may have its own operator. There will be automation controllers. The word operator, I guess maybe I'm talking about this. Operator is a sort of generic term. It's more about how you package up a bunch of Kubernetes controllers. So Kubernetes controllers sort of typically manage an individual resource, and then an operator may be a collection of controllers that work together to manage some particular business function, or business is a strong word there, but some particular domain that's like an application. So when I say an operator, I mean here's an operator for the free 5GC UPF or whatever, or maybe it's for the whole core. Like you could build one that's for the whole core, right? But it's some coherent set of functionality, and within it there are like dozens or hundreds individual controllers to manage individual types of resources. Just to kind of give the terminology. So we'll have operators not just for those three domains, but for but many operators that each fall within one of those three domains. And I would say, Jean-Marie.
Thank you.
Is it really operators that matter from that SIG perspective, or are really the custom resource definitions?
Both. They go. It's really the controllers that it's not.
No, it's not. Provided a set of controller is satisfying and is controlling a certain set of custom resource definition or custom resources, that's what should matter from our perspective. And if we are not having that level of robustness, we are building an architectural fragility that will be problematic.
No, yeah, I 100. If I understand what you're saying, I 100% agree. So definition of those CRDs, like, is critical. So it'll be like a Nefio API group CRD that talks about some aspect of a UPF configuration. I don't know all the details of Tilka stuff, so maybe I'm saying something that doesn't make sense, but then there'll be a Nokia operator, there'll be an Ericsson operator, there'll be a Casa Systems operator, there'll be a free 5GC operator that all consume that same resource that represents what's common about a UPF. They will also have their own CRDs that deal with their own differentiated features and their own things that they have to do. And the tricky bit, or the interesting bit, maybe is a better word, is what other operations, what other actors can act upon that same CRD in order to get it into the state that it needs to be consumed. So right, there's the two sides of it. There's you start with the high level intent and you translate it into something that can be consumed. The operator running on the edge cluster consumes that and makes it real. So the interface point between them has a commonality section and has a vendor specific section. And the Nefio, the automation pieces of Nefio really will only be able to act on that common piece, other than sort of act opaquely or in sort of, there's certain operations you can do, like change the image tag in every resource, right? You could act across both of those because they're both Kubernetes style configurations. So there's certain broad cross sections of configuration, bulk edits, changes you can make. You can use the same tooling, but the automation pieces that do stuff like, oh, I need to, punch out 3 different versions of this for 3 different clusters. They can punch out 3 different namespace names, because those are understood across both the vendor specific and the common thing. But as far as things like that are very require knowledge of the API itself, deeper understanding, they can only act on the common piece. So the trick is, like, how much can we put in the common piece that we can effectively manage the automation, that provides utility, right? The whole point is that it's useful. And if there's so little in the common piece that there's nothing you can do with it, then it's probably not useful. You could still use the overall machinery for setting things like namespaces or common attributes across the resources. But anyway, I went off a tangent again, but the main point is 100% agree with you. It's those CRDs that's most important, not how they're actuated. That's going to be individual vendors and individual people who actuate the same set, depending on what they're working on. Tal.
So yeah, I like this conversation, even though it's probably more suitable for the architecture of SIG, right? That's where the CRDs will be defined. But of course, this is the SIG that will implement them. So we do need to discuss it here. I think there are 2 philosophies to it. I think one in which you stated pretty well that there's it's that careful balance between lowest common denominator and leaving room for differentiation, right? That's always a very difficult part of modeling. And you mentioned even earlier the object-oriented world where it gets even more extreme, because the base type really has control over the whole tree, right? So yeah, there's a lot of weight in our CRDs. However, I think there's another philosophy that we can think of and even combine with that, which is the Unix philosophy, where you divide things up into functional tasks, and you have a tool that just does one thing very, very well, and that's it. It doesn't care about other things. So, yesterday we mentioned, for example, bias configuration, right? What if we want to express the BIOS configuration, redfish, or whatever it is for a specific machine in the cluster that a network function needs. Now, the network function doesn't know where it's going to run on the cluster, but it could specify with some sort of custom resource, this is my requirement, and the operators will make it happen magically, right? Auto-magically. But we can really think if our CRDs are functional blocks rather than trying to define the whole network function completely. So if we decompose it into what are the actual pieces that are needed, this kind of network connectivity, this kind of Yang configuration, netconf configuration, each of these can be a separate operator that just does that, right? So whatever you end up using could be just an assemblage of these CRs that you happen to need for that network function, right? So the most useful solution for us might be somewhere in between, right? Maybe having these kinds of low-level building blocks, but also having some sort of higher-level overall operator for the complete network function that can manage it and maybe even talk to the other operators. There's a lot to discuss here in terms of architecture. That should happen in SIG #1, but I guess a lot of that conversation will happen here too.
So the SIG #1 will give us the use cases and requirements, but the CRD will be defined here, right? Or is CRD going to be defined in SIG 1?
Yeah, that's the idea. Yeah, I mean, we're not overloading users, which are mostly network architecture SIG is about.
So CRD is going to be defined in this.
Also, be defining CLDs and interaction between operators that I don't think they'll be defining that at all.
Oh, okay.
Yeah.
So CRDs will be defined in this, not in the only requirements will come from.
They'll give us use cases. Yes.
Okay.
Which means
Potentially information
which means also that the information model belongs to SIG 2. Because basically the set of CRDs is the information model.
Well, I guess it depends on, so what I'm imagining, CRD to me, I don't know. It's a good question. To me, it seems like the information model, there's a distinction in my mind between the logical model and the physical model. Like when I used to do 15, 20 years ago, the database design, it would be like you build the logical model and then you do your physical model.
Okay, technically, a set of CRDs is a data model that is conformant to an information model.
Yes,
okay.
That's how I think of it. Yeah.
But
yes,
but SIG 2 owns the data model, and I don't know if SIG 1 will do actual information model.
I don't know either. Like it was brought up. I don't remember if it was you who brought it up, but it was brought up that information modeling belongs there, and I'm okay with that. That works for me. Not that it's up to me. Randy?
Yeah, just wanted to propose that, as Tal alluded, there are many pitfalls we can spend our time on, and choosing between, very generic CRDs with a lot of bells and whistles or smaller ones. What I was going to propose is maybe not spend too much time on that and just try to create things that work, maybe for Nephew 1.0, with the keeping in mind that we might throw away some of the stuff in Nephew 1.1 or 2.0, and let's just create things that work and not worry too much and create an analysis paralysis because we are dead on choosing the right approach. So I think we should prefer pragmatic things that work now, and be prepared to ditch them in 2.0 or moving forward. That's all.
Yeah, right. Even best practices could be evolved over time.
Yeah.
Yes.
Okay, well, we're pretty much out of time.
So are we? Okay.
Yeah.
Yeah, 2 more minutes. So anyway, so like John, on the next meeting, I intend to either post seed codes or at least some level of seed codes to pull request, so everyone can look at, and then we can get the discussion from there.
Okay.
Hi, just a logistic question. I mean, is there one place where you could access all the content happening from the SIG? I mean, or is it like 3 different URLs?
No, this is a really good question. We talked about this in SIG release yesterday, and we're sort of struggling with the choice of which tooling to use. I did share a folder You should have got, if you're in the Google group, you would have gotten an email saying we shared a folder that has this document in it, but and we can put other things there. But there's also discussion of whether this should all be on the wiki, and so I think we need to, and that sort of falls all within SIG release to decide on that tooling. We talked about yesterday. We would send out a note or maybe a survey of some kind. You know, there's advantages and disadvantages of both. So yes, thank you, Shal. Unfortunately, right now it's a little bit messy. I hope that over the next couple of meetings we'll get that straightened out and we'll know better where. But so now right now there's sort of two places: the wiki, and then this document, you know, this folder that I shared, which really only has this document in it, and it'll have the videos, but I'll also put the videos on YouTube, and then there'll be GitHub for actual like code and stuff.
Okay, thank you.
Yeah. All right. Thank you, everybody.
Thank you.
Thank
Thank
you.
you.
Bye.
Bye bye.
Great
Thank
work. Thanks.